Hello, you absolute legends. My name is Don Kavanaugh, and I'm going to do the vitamin C titration, and I'm going to do a trial start to finish with all the calculations. I did my quick and dirty trial with about 0.1 grams exactly of vitamin C, and my quick and dirty trial took about 6.7 milliliters. So I'm going to weigh out exactly that much again, and I'm going to do it painstakingly. So I want to get my mass of vitamin C identical from trial to trial, because it just makes things speed along faster when I know the milliliters I'm shooting for. That's probably, oh, there we go. I'm going to take out a little bit. All right. So that is my 0.10 grams, and I recharged my burette to 0.00 milliliters. Let me show you. All right, now I'm going to make my sample 1. My 0.10 grams of vitamin C is going to go in my trial 1 beaker. That's trash. And now I'm going to fill this up with about 50 milliliters of water. It really doesn't matter how much water you add. I just need everything dissolved. So I'm going to err on the side of 50 milliliters, just so things dissolve. And then I'm going to swirl this around. And it might take me about 45 seconds to a minute to get everything to dissolve, but it's important that everything is dissolved. I'm going to add 5 drops of indicator phenolphthalein. 1, 2, 3, 4, 5. That works. If you did 6 by accident, no big deal. All right, so right now, I want to make sure that I have my burette set up. Trying to make sure that all of that solid is dissolved. It's just a waiting game. Just going to keep swirling it. All right, I don't see any more crystals now floating at the bottom. All right, all the crystals are gone right here. I have the molarity of it right here, and it's starting at 0.00. My first trial was 6.75. I'm watching it up here, and I'm going to blow through the first 5 milliliters like you wouldn't believe. 2, 3, 4, 5. Then I'm going to stop it. All right, so looking down here, it started to turn pink. But you see it disappeared there kind of very quickly, okay? So I'm going to try to just add drops right now. Okay? Now, right now, it is at just over 4.5 milliliters. So I'm going to add, this might take some time. Whoopsie daisy. But I'm just going to keep adding a little bit right here. And you see I'm just kind of doing burps with a baby bird, like a baby bird. So I'm just over 5 milliliters, so I know I'm getting close. 5 drops. Getting close. I'm going to try to add 2 to 3 drops at a time now. It's dripping pretty slow, so I'm just going to try to swirl and see if I can catch the faintest shade of pink. What I'm trying to do is I'm trying to watch the pink color, and I want it to flash. All right, I'm gonna let one more drop go. All right. So it's still not quite pink. It's at 6, it's just under 6, it's just like 6.3 milliliters. So I know I'm close. I'm probably going to have a drop. I'm probably less than 5 drops away. Let's see how my bet is. That's 1. And I'm really just being very careful with the stopcock. That's 2. That's 3. All right, getting closer. Whoopsie daisy. Definitely getting close. I'm over 6.5 milliliters. Did that ruin it? Nope. Still getting close. All right, so I overshot at that time, but that's okay. That is the number right there. I'm going to swirl that up. Okay, so this right here, I'm going to try to read that to 2 decimal places. It's very hard to see right there. Looks like it's about 6.94, 6.91 maybe. Gotta look at it a little closer. I'm going to say that's 6.91. It looks like it's just under the 6.91 line. All right. We are going to now do our calculations here. The final burette reading was 6.91 milliliters. 6.91 milliliters. The moles of NaOH used is going to involve calculating using the milliliters and the moles per liters in a scaffold. Make sure you do your conversions of liters and milliliters. So I want to find moles. So I'm going to start with moles in the numerator. And now I'm going to add in those milliliters. .91 was what we did for the trial there. So as this sits right here, this would give me the moles of NaOH that was dispensed. Divided by, so 0.000656 moles. Now the grams of ascorbic acid that must have been present right there. Now the base to vitamin C ratio is a 1-to-1. So if there is 0.00656 moles of NaOH, that means that there are 0.000656 moles of vitamin C. Vitamin C, we want the grams though. Vitamin C has a molecular weight of 176 grams per mole. And we said that there was 0.0000656 moles present of vitamin C. They are in a 1-to-1 ratio, the base and vitamin C. So that unit cancels there. I definitely overshot. 0.1154 grams of vitamin C were present in that sample right there. I definitely overshot for a bit right here. Let's do the final calculation in this trial right here. So that is 0.1154 grams of vitamin C. Now the very final calculation of each trial is the percent of ascorbic acid in the sample. I measured out initially 0.10 grams of vitamin C. I did that on the balance over here. Cannot deny that right there. Now my calculations were 0.1154 grams. Okay, that's the amount that I determined was present. that's the amount I actually weighed out times 100%. You could probably see, hopefully you can see where this math is going. This is going to go to over a 100% sample, which doesn't make any sense. But I kind of overshot this sample when I was doing it over here, so I'm not really surprised that I got an unrealistic number right here. Okay, so this is 115%, definitely an unrealistic number, but it is what it is right there. When I do my next trial, 2, 3, and 4, I'm going to try to get an even fainter pink and narrow it down to 1 drop. I hope this helps. Thank you.